All right, so for 3.6, polynomial and rational inequalities. So we had started talking about inequalities on the last section, but we were just doing linear inequalities. So we only had variables so we only had x, we didn't have any x squared. We also did not have any variables in the bottom because we did not have any fractions or rational expressions within our inequalities. So these are a little bit more involved. So definition of a polynomial inequality. Basically, it's going through and it's just telling you that you're going to want to set the entire thing on one side, so to the left, and then have 0 on the right. Once we get it set up like this, then we've got a process to go through and solve it. That's going to be, it's not hard, but I will tell you it is kind of a long process. So it's got quite a few steps, but it's not a hard process. All right, so once we get it set to where we have the polynomial inequality on the left and then a 0 on the right, we're going to go through and we're going to solve it pretending that it equals 0. So essentially that means we're going to end up factoring, or we're going to end up using the quadratic formula or something like that to figure out what values make it equal 0. So what values of x make it equal 0. Those are going to be our boundary points. At this point, I always draw a number line. I mark my boundary points. And then a test value is going to fall in between boundary points. So essentially, we're going to be taking a number line. We're going to break it into a couple of pieces. So for our boundary points, and again, the boundary points came by setting it equal to 0 and solving for x. So if I end up with those 3 boundary points, then I need to pick a test value in between all of them. So that also means everything to the left of the lowest boundary point, everything to the right of the highest boundary point, I actually need values within those areas as well. So I'm going to have to pick test values that are in all of these places. You will have one more test value than you do boundary point, basically is what it'll come down to. Then we're going to go through, whenever it's a test value, it's exactly that. That means we're going to take that value that we picked and we are going to test it to see if it's true. So we're going to plug it into the polynomial inequality. We've got everything on the left side and a 0 on the right. We're going to plug it into that and see if it's true. Once we figure out which of these intervals is true, then we can go through and write our solution. So it's not quite as bad as it sounds. So for this one, we've already got everything on the left, 0 on the right. So for this one, x minus 4 times x plus 2 is greater than 0. Now we need to find where the values of x that make the left side 0. Because they were nice, they already factored it for us, and it's a quick process. So to find our boundary points, we're just going to take the factors and set them equal to 0. And if we solve, we're going to get x is 4 and x is negative 2. Oops, equals negative 2. All right, so we have x is 4. So we have one right here. And negative 2. So we have one right here. Again, these are the boundary points. So once we have the boundary points, we're going to need test values. I always set this up as a chart because it just helps me. So I'm going to need a test value. I'm going to think about plugging that test value into the x minus 4 times x plus 2. And then I need to determine if that is greater than 0. All right, so for my test values, I need to pick something less than negative 2, something between negative 2 and 4, and then something greater than 4. So pick a number less than negative 2 for me. Negative 6, sounds good. I need something between negative 2 and 4. I actually have a preference. What do you think my preference is? 0. Yeah, anytime you've got 0 as an option for a test boundary, pick it. It's normally going to be pretty easy. And then we need something greater than 4. 5 sounds great. All right, so I'm going to think about plugging these in, And you don't have to do this much work with it, but just to try to get the point across. So we have negative 6 minus 4 times negative 6 plus 2. Well, this is the same as a negative 10 times negative 4. So a negative times a negative gives us a what? A positive. Is a positive greater than 0? Yeah, true. So this negative 6 test value is true. We'll come back and mark it in just a second. So now we plug in 0. So we're thinking about this being 0 minus 4, 0 plus 2, which is the same thing as a negative 4 times 2. Negative times a positive gives you a what? A negative. A negative is greater than 0. Is that true? So that's going to give you a negative, which is going to definitely be less than 0. So this one's false. All right, now let's do it with 5. So again, we're going to do 5 minus 4 and 5 plus 2. So this gives us 1 times 2. A positive times a positive is a positive. A positive is greater than 0. Yeah, that's true. Yes, ma'am, what's your question? Oh, yeah, 5 plus 2 is not 2. 5 plus 2 is 7. Thank you. However, it still works out, right? So the 1 times 7, the two positives are still going to give us a positive, and the positive will still be greater than 0. Yes, thank you for that. We don't actually have to go through and figure out the values here. We really need to know if it's positive or negative. And once we figure that out, we're good. Part of the reason I do values is that whenever I taught this a while back and I just tried to use signs, people found it a little bit confusing. So it's just easier. So whenever I'm getting to here and I'm saying negative 10 times negative 4, 2 negatives make a positive, that's really the only part we care about. But if you want to go ahead and multiply it, get a positive 40, and then go 40 is greater than 0, that's a good, right? That works. So you can get the exact value, it's just a few extra seconds for you. Yes, thank you for pointing that out. All right, so let's go back and we're going to end up marking what we got. So we have, we got our test value of negative 6. So here's our negative 6. That means it is this part, because that was our test value for less than the negative 2. So we've got this going. It was true. At this negative 2, parenthesis or a bracket. The bracket would include it, correct? The parenthesis will not. We're going to have to use the parenthesis because our inequality doesn't have the or equal. So we're going to put a parenthesis here. All right, our next true one was whenever we had a test value of 5. So my 5's here, which means that this interval is true. Does that 4 get a bracket or a parenthesis? Parenthesis, right? Okay, so now we've marked everything that's true on a number line. My math lab will have you do the number line, but it really is going to want the interval notation. So how do I write this first interval? Yeah, negative infinity to negative 2. I'm going to leave a little space. How do I write the second interval? Yep, parenthesis 4 to infinity, and then close it. All right. Now, it's both of these things that work. So I'm going to put a big U. Hopefully you guys remember from Unit P, that's your union sign. So the union means that it's both of these will work. So again, it's hopefully not that hard of a process, but it is quite a few steps, right? So you gotta get boundary points. Then we have to do our little test values in our chart, figure out if the test values make it true or not, mark it on your number line, and then go through and give the interval notation. So again, a lot of steps. Yes, ma'am. Right. So we're only marking the true on the number line. The false, we're not marking that because that for sure isn't involved in it. Yeah. Yes, there will be some instances where it could be everything, which actually is a really good question. So if it was all three, so if this was true, actually I'm going to not do that yet because this one would still be, for this one, if we had all three being true, then we would have to go through, write this interval, union, write this interval, so parenthesis negative 2, comma 4, close parenthesis, another union, and then write the third piece. And we will have problems where it's 2, 3 intervals that you're going to have to put the union in between all of them. Yeah, very good question. Okay, I'm going to give you all a minute to try it. All right, we'll start on it. Even if you're not finished, we'll go ahead and get started. So again, the first thing we need to do is find our boundary points. And so we're going to do that by taking the left side, so the polynomial, setting it equal to 0, and finding what values of x make it 0. Because they were nice, they already have it factored for us. It's a quick process. So we know x plus 1, and we're going to set that equal to 0. Oh, did not need my parentheses there, right? And don't need them here either, so I'll leave them off on that one. So this one is going to get x equals negative 1, and x equals 7. So we've got a negative 1, so here's a test boundary. And x is 7. There's another one. There's another boundary point. And then I'm going to make my chart. So I need test values. And then I'm thinking about what it's going to be whenever I plug that into x plus 1 times x minus 7. And then I want to figure out if that is less than or equal to 0. All right, so test values. I'm going to need a test value that is less than negative 1. What's a good number? Negative 2 sounds great. What's going to be the preference between negative 1 and 7? Yeah, and then bigger than 7. 8, okay. So we're going to plug those in. So we got negative 2 plus 1. Negative 2 minus 7. So the negative 2 plus 1 is going to give us a negative 1. The negative 2 minus 7 is going to give us a negative 9. A negative times a negative gives us a what? Gives us a positive. A positive is less than or equal to 0. False, correct. So that's going to be false. All right, let's plug in our 0. So now we're going to have 0 plus 1 times 0 minus 7, which gives us 1 times a negative 7. A positive times a negative gives us a negative, right? And then a negative is less than or equal to 0. True. All right, let's try 8. So we're going to have our 8 plus 1 times 8 minus 7. So the 8 plus 1 gives us a 9. The 8 minus 7 gives us a 1. A positive times a positive gives us a positive, and a positive is less than or equal to 0. No, not true at all. So that's going to be false. So the only part that worked was this middle one whenever we use the test value of 0. That test value of 0 is falling between that negative 1 and 7. So we know that this is true. So this is true. Then in our negative 1, we're going to have parenthesis or bracket. Bracket. We're having a bracket because of the or equal. And then at the 7, parenthesis or bracket. Bracket. Correct. Because again, that or equal part. All right, so our answer in interval notation is going to be what? Bracket. Negative 1 to 7, correct? And a bracket. Exactly. So there is our interval notation answer. That okay? All right, for C, it's got an extra step, right? What's the extra step? Yep, move it all over to the left side, correct. So for C, we can't get started because we don't have a 0 on the right. So to get a 0 on the right, we're going to move all these over. So to do that, we're going to subtract 2 from both sides and add 3x squared to both sides. So if we do that, we're going to end up with 3x squared plus 5x minus 2. And then that's going to be less than or equal to 0. Is that all right? Okay. All right, then we need to factor this guy. We could use the AC method. You You can use a calculator. I'm going to think about it for just a second. So the 3x and 3x squared has to be split up to 3x and x. That we know. Because this is a -2, I know I'm going to have opposite signs. So I'm only dealing with a 2 and a 1. And I need to add to a +5. So my thought is, if I can only have this as a 2 and a 1, and I have this, the coefficient, the number in front, being split to a 3 and a 1, then if I multiply to 6 and then subtract 1, I can get to 5. So I want this 3 to multiply by a 2 to get to my 6. I need to be a +6 because I need to add to 5, so it's going to be a positive there. And then I need to subtract 1. So if I double check myself, 3x times 2 is going to give us 6x, and then -1 times x will give us -x. So the 6x minus x is going to give us the +5x. So we kind of double check there. Now we'll find our boundary points. And we're going to set each factor equal to 0. So 3x minus 1 is 0. X plus 2 is 0. So here if we solve, we're going to add 1 to both sides and then divide by 3. So that's going to give us that x is 1/3. So we added the 1 to both sides and then divided by 3. And then for this one, we're just going to subtract 2, so we're going to get x is -2. Is everybody okay on that, even though I didn't show the steps on the 1/3 part? Okay. All right, so x is -2 right there. And then x is 1/3. All right, well, that 1/3 is going to be about here. And I'm going to make a note. That's a 1/3. And then same process. So we're going to be looking for our test values. We're going to be plugging those into 3x minus 1 times x plus 2. And then determining if that is less than or equal to 0. I'm going to give you all a minute to try from here. All right, so we need to test values. What did you pick that was less than -2? -3 sounds good. What did you pick between -2 and 1/3? Yeah, 0 is good. What's bigger than 1/3? Yeah, 1 sounds pretty nice also. All right, so we've got 3 times -3 minus 1 times -3 plus 2. So that's these. 3 times -3 is a -9. -9 minus 1 is going to give us a -10. And then -3 plus 2 is going to give us a -1. All right, so a negative times a negative is a positive, and a positive is less than or equal to 0. False, right? Positive is never less than 0 or equal to it, so false. All right, let's plug in 0. So we're going to have 3 times 0 minus 1 times 0 plus 2 equals 3 times 0 is 0. 0 minus 1 is going to give us a -1. -1, and then 0 plus 2 is going to give us 2. A negative times a positive is a negative, and a negative is less than or equal to 0. True. All right, now we're going to plug in 1. So we have 3 times 1 minus 1, and 1 plus 2. So 3 times 1 is 3. 3 minus 1 is going to give us 2. And then 1 plus 2 is going to give us 3. Positive times a positive is a positive, and a positive is less than or equal to 0. False. All right, so not that one. The only one that worked is when we plugged in the 0. That 0 fell between these two right here. Are they getting parentheses or brackets? Brackets. Because of that or equal. So we've got the bracket, -2, to 1/3, and then close it with another bracket. Is that okay? All right, good. Okay, for D. So D has everything on one side, which is good. It has 4 terms, which is a little odd. We're used to using 3. How do you think we're going to factor this guy? All right, so we have forgotten how to factor 4 terms. How about by grouping? So factoring by grouping means we're going to look at these first two terms, see what's in common, and pull it out. So what's in common between x cubed minus 3x squared? X squared. All right. So we've got x squared. What's left? X minus 3. Beautiful. All right. For the second part, so now we're going to look at this negative 9x and this positive 27. Whenever you factor by grouping, you're going to 99% of the time use this sign. So minus. So what's in common between the 9x and the 27? More than 3? 9. So we're pulling out this negative 9, okay? So if you pull up the negative 9 times what gives you negative 9x? Yeah, just x. And then negative 9 times what gives you a positive 27? Negative 3. Beautiful. Okay, and then, so we're factoring by grouping. This little thing here matches, right? So we're going to pull that out. So x minus 3 matches. We are left with x squared minus 9. And that's going to be less than 0. Are we done factoring? No. That x squared minus 9 will factor, right? So, keep that x minus 3. X squared minus 9 factors into what? Yep, x plus 3, x minus 3. Does it matter that I put the plus first? No, it doesn't matter at all. Okay, so now we finally got it factored. So now we can go find our boundary points. And we're going to set x minus 3 equals 0, x plus 3 is 0, x minus 3 is 0. So we're going to get x is 3, x is negative 3, and then we're going to get x equals 3 again, right? Well, that's fine. We're just going to mark it once. Because marking the 3 twice doesn't do us any. It doesn't make it any more special. So we have our points at negative 3 and positive 3. So there's our boundary points. All right, I want you all to set up and go through and do your test values. All right, we need some test values. So what test value less than negative 3 did you pick? Negative 4. Sounds good. What about between negative 3 and 3? Thank you for picking the good one. And bigger than 3? 4. Sounds good. All right, so we're just going to plug this in. So we have negative 4 minus 3, negative 4 plus 3, and negative 4 minus 3. So negative 4 minus 3, oh, that's an equal sign. It's a very bad equal sign. Fix that. Equals. So we're going to have negative 7. Negative 4 minus 3 is going to be a negative 1. And then another negative 7. So 3 negatives give you a positive or a negative? Gives you a negative. A negative is less than 0. True. All right, so that's looking good. Now, when we plug in our 0, so we're going to have 0 minus 3, 0 plus 3, and 0 minus 3, which is going to give us negative 3 times a positive 3 times a negative 3. 2 negatives and a positive gives you a positive value. A positive is less than 0. False. Correct. False. All right, now let's plug in our 4. So we're going to have 4 minus 3, 4 plus 3, and 4 minus 3. So the 4 minus 3 is going to give us a 1. 4 plus 3 is going to give us a 7. 4 minus 3 is going to give us another 1. 3 positives gives us a positive. Positive is less than 0. False. So we only had one interval that works. And it was whenever we plugged in that negative 4. So we know this is the interval where it works. Does the negative 3 get a bracket or a parenthesis? It's going to get a parenthesis because there's no or equal. So for our interval notation, we're just going to have negative infinity 2 and close it with a parenthesis. Perfect. Is that all right so far? Yeah. Okay. So if you have an or equal, the or equal is the only time you might use a bracket. And I say might because of the next page. So whenever we have the or equal, so far we've been using brackets. But it starts to become questionable if we're going to need it or not whenever we get to the rational inequalities, which is this page. So the first one's going to be just kind of set to the point. And I'm going to actually help you get your boundary points and then let you guys do the rest. The boundary points for this, the only reason this is any different than the last page is that instead of just having to factor the top and get what makes it equal to 0, we also have to set the bottom equal to 0 and see what's going to make what values of x make the denominator 0. So, to find the boundary points, we're going to set x plus 5 equal to 0 and x minus 2 equal to 0. So this will give us x equals negative 5 and x equals a positive 2. So we got a negative 5 and a positive 2. Now it does not matter in this problem, but at the x equals 2, where that's a boundary point, we cannot ever have x equal 2 because that would be dividing by 0, correct? So we cannot include any value that would have us dividing by 0. So we know for sure that that 2 would have to have parentheses added. Like I said, for this problem it's irrelevant, but just want to make you aware of it. So I want you all to go from here, go through, get your test values, test it, and this is where you're going to start to see that thinking of it in terms of how many positives and negatives you have makes it a little bit easier. And then figure out which parts are true, graph it on your number line, and then also give the interval notation. All right, what test value did you pick that was less than negative 5? Negative 6 sounds good. What about between negative 5 and 2? 0 sounds good. And then what about bigger than 2? 3 sounds good. All right. So we're thinking about this as a negative 6 plus 5 over negative 6 minus 2. So it's going to give us a negative 1 over a negative 8. So two negatives give us a positive, and a positive is greater than 0. Yeah, it's true. Is that okay with everybody? Even though it's division, we're still just counting the negatives? So, okay, so the test value is coming from, we found our boundary points. So we have a boundary point at negative 5, and we have a boundary point at 2. So we've split the number line into 3 pieces. We have to find test values that are in each of these pieces. So negative 6 is testing this piece of the number line. The 0 tests this piece of the number line. And that 3 is going to test this part of the number line. So it's going to be in between. So we're using boundary points to figure out where we're splitting the number line. So once we have it split into 3 pieces, we need to pick test values that are in each piece. So not the boundary point, so not equal to 0. We're looking for something in between, so each interval or each section. Did I answer your question yet or no? It doesn't look like it. What value did you pick for your first test value? So, okay, so where you pick negative 4, that's the same as where we pick 0. Because your negative 4 is in this middle interval. So you picked here. All we did was pick 0. It doesn't matter which of those we pick to test that middle interval. Correct. Yeah, so for whenever we pick negative 6, I could have picked negative 7, negative 8, negative 9, negative 10. I could pick negative 10.5. I could pick negative 1,000,000. But we're typically just trying to pick numbers that are going to make our calculations easy. So, I mean, negative 1,000,000, I guess, would make it easy, but I don't want to write all that out. Right, exactly. All we're trying to do is figure out that whenever we pick one of these test values, if it's going to end up giving us a true or false statement. So meaning for this one, if it's going to be greater than 0 or not. And the reason we're always having it greater than, equal to, less than, equal to, and 0 is because we can go through. We can just figure out the positives and negatives and figure out if it's going to give us a positive answer to be greater than 0, give us a negative answer in that which will be less than 0. So the 0, and again, the 0, we're picking any number between -5 and 2. We cannot pick the endpoints. We've got to pick in between. 0 we pick because it usually makes things nice and easy. But -4, -3, -2, -1, 1 would have worked. So now we plug in our 0. We're going to have 0, oh, okay, that's fine. 0 plus 5 over 0 minus 2, which is going to give us 5 over -2. Is this going to give us a positive or a negative answer? Negative. Because we have a positive and negative, which gives us negative. A negative is greater than 0. False. So when we plug in our 3, we're going to be thinking about 3 plus 5 over 3 minus 2. So the 3 plus 5 is going to give us 8. 3 minus 2 is going to give us a 1. Two positives give us a positive. A positive number is greater than 0. True. All right, so whenever we're up here, we're going to be marking that -6 fell to the left of that -5. So we've got this part. And then the 3 was to the right of that 2. So we've got this part. And then at the -5, parenthesis or a bracket? Parenthesis, correct. And at that 2, parenthesis or a bracket? Parenthesis, right. We're using these parentheses because we do not have an or equal, but at that 2, we would have had to have used a parenthesis anyway because we can't divide by 0, so we cannot include that 2 regardless. All right, so our interval notation for this would be what? -infinity to -5. Parenthesis, yep. And union, beautiful. And then our next part? Perfect. So, and then parenthesis 2 to infinity. So there's our interval notation for it. You can only use a bracket if there's an or equal, and you won't always, you won't blindly use brackets just because of an or equal. All right, I'm going to give you all a few minutes to try B. All right, we'll get started real quick. So to get our boundary points, we need to take all the factors, so in the numerator and the denominator, so the top and the bottom, set them equal to 0. So we got x plus 3, set that equal to 0. X minus 2, set that equal to 0. And x plus 1, set that equal to 0. So we know that x, or we're going to have boundary points at x equals -3, at x equals 2, and at x equals -1. So -3, oh, thank you, -1, -3, -1, and 2. So there's our boundary points. Test values. What's your first test value? -4. All right, what's your next one? -2, 0, and 3. Beautiful. All right, let me space those out a little better. Okay, so we're going to plug in our -4. So we have -4 plus 3 times -4 minus 2 all over -4 plus 1. So -4 plus 3 gives us a -1. -4 minus 2 gives us a -6. -4 minus 1 gives us a -3. 3 negatives give us a negative. A negative is less than or equal to 0. True. All right, we'll try it with a -2. So we got -2 plus 3, -2 minus 2, and -2 plus 1. So the -2 plus 3 is going to give us a +1. -2 minus 2 is going to give us a -4. Negative 2 minus 1 gives us a negative 1. Two negatives and a positive give us a positive. Positive is less than or equal to 0. False. All right, let's do the 0 now. So we're going to have 0 plus 3, 0 minus 2, over 0 plus 1. So that gives us 3 times a negative 2 over a positive 1. Two positives and a negative give us a negative. A negative is less or equal to 0. True. All right, one more. So we're going to plug in 3. So we have 3 plus 3 times 3 minus 2 all over 3 plus 1, which gives us 6 times 1 all over 4. So 3 positive gives us a positive. So 3 positive gives a positive. A positive is less than or equal to true. False. All right, so this one's a tiny bit trickier. Not for this part, right? The marking it. So the negative 4, okay, negative 4 was true, so we know back here is true. And then we had 0 was true. So if the 0 was true, 0 is here, which means it's between these two boundary points. Yes, we're only marking the trues. Only marking the trues. So at the negative 3, so everything less than the negative 3, at the negative 3, parenthesis or a bracket? Bracket. All right, I'm going to skip. Let's go to the 2. Parenthesis or bracket at the 2. Bracket. At this negative 1, parenthesis or bracket? This is the tricky one. Parenthesis and y. Can't divide by 0. So that one has to be a parenthesis because you can't divide by 0. So for here, if x is, we know that x cannot ever be negative 1. So there's the tricky part that will get you. So for our answer, what is an interval notation? Yep, negative infinity to negative 3, bracket. Okay, union, and then parenthesis, negative 1. Yep, to 2 with a bracket. Beautiful. The parenthesis for the negative 1? Oh, okay, yeah. So because of this or equal, we're thinking about having brackets because that means it can equal 0. So if we pick x is 3, then this whole value, this is going to be 0 over 4. Sorry, if we make negative 3, it'll be 0 over negative 2. But regardless, it'll be 0. And because of this or equal, it can be 0. So we can include that negative 3. If we pick the 2 is going to make this top 0. So we'd end up with 0 over 3. 0 over 3 is fine. It's equal to 0. And 0 is less than or equal to 0. If we pick negative 1, we end up with a number on top over 0. And because we can never divide by 0, we can't include that point for any reason. So that negative 1 makes the denominator 0, which doesn't exist. It's an invalid option. So that negative 1 we know has to have parentheses. As a little side thought, so we had something like x over something like this. To find the boundary points, we know that we're going to have x is 0 for the top one. And then we set 2x minus 6 equal to 0. Whenever we go through and solve, we're going to move the 6 over and make a positive 6. So 2x equals 6. Divide both sides by 2. We're going to get x is 3. But we know that x can never actually be 3 because that's going to make this turn into 0. So if you want to mark it a little bit better, so mark that x isn't going to ever be 3 regardless. And then on your number line, So we would have our boundary points at 0 and 3. So at 0 and at 3. One of the things that I've done in the past is that before I did anything, because I knew that x couldn't be 3, I would go ahead and lightly mark parentheses facing both ways. So I remembered, okay, I'm not actually using these yet, but just to remind myself, it has to be a parenthesis at that 3. Regardless of what intervals work, at that 3, it's going to have to be a parenthesis. So marking something like that as soon as you're doing the boundary point, and however you choose to mark it is good. If you want to like put a little star over it so that you know, pay attention to that at the end, whatever you want to do. But make a point that any value that makes the denominator 0, it's going to have parentheses.